Hey Algebra 2, this is the video for Friday. This is for L and K. I just want to show you this first page. This is where we're going to get a lot of our information today that we're going to be talking about throughout the notes. It should be on that blue piece of paper that you should have in front of you right now. This is going to go to page 5 of your packet. When we return, we'll do page 6 together, and then 7 and 8 is that review if you want to start working on it. This right here is going to be some new information, but you're also going to kind of find it familiar, especially that quadratic formula that you saw back in Algebra 1. I know that's a while ago, but try to remember back. So here we go. We're going to start with this very first problem where it says find the type and numbers of solutions for each equation. So the way that we're going to do that is we're going to use the discriminant. And the first thing we want to do is make sure this equation is in standard form, which notice it's not. I need to subtract x. So I have 10x squared minus x plus 9 equals 0. That's the standard form equation that I want first in order to be able to use that discriminant. And the discriminant is going to refer back to this right here. This right here is my discriminant that I'm going to use for that. So I'm going to use that formula b squared minus 4ac. Notice each of these are here. So I'm going to have b squared, which is understood to be negative 1 squared, and notice I put that in parentheses on purpose, minus 4 times a, which is 10, times c, which is 9. Plug that in your calculator. So go plug that in. You're going to plug in open parentheses, negative 1 squared minus 4 times 10 times 9, and hit enter. You're going to get the answer of negative 359. Okay, again, there's what it looks like on my calculator screen if you want to refer to that. So now that I see that, that's going to tell me my type and my number of solutions. So my type is going to be imaginary. And then my number, since it's imaginary, is going to be 2 imaginary solutions or whatever. The negative right here is what tells me that it's imaginary, and then we know that it's 2. Look right here at this chart, it says when it's less than 0. Well, less than 0 means negative, that there's 2 non-real, complex, imaginary. You can call them any of those. We're just going to go short for 2 imaginary solutions. Number 3. Number 3, again, is not in standard form, so I'm going to add 5 to both sides. I get 8x squared plus 6x plus 5 equals 0, and I'm going to plug it into that discriminant. So here we go into the discriminant. I've got I got positive 6 is my b term, squared minus 4 times 8 times 5, and then I'm going to plug that in my calculator. So 6 squared, again, don't forget those parentheses, minus 4 times 8 times 5, hit enter, and you're going to get negative 124. So here it is. Again, it's negative, so that means I've got 2 imaginary solutions. Okay, so anytime you're trying to find the number and type of solutions, you're using that discriminant formula, which is that b squared minus 4ac. Take each number. If you don't realize this is going to be a, b, c, a, b, c. That's what we're doing for those. Go ahead and pause the video and try to do number 4 and 5 on your own. Try to do number 4 and 5. At least find the discriminant for me. Alright, so here we go. Again, put it in standard form. So 8x squared minus 16x plus 8 equals 0. Plug that into that discriminant formula. So you're going to have open parentheses, don't forget that, negative 16 squared minus 4 times 8 times 8 equals 0. So I'm going to plug that in my calculator, open parentheses, negative 16 squared minus 4 times 8 equals 0. And if you go back to that very first top piece of your paper, right here it tells me when it equals 0, there's only one real solution. So my number would be 1. And I would have a real solution. You can either write the number 1 or you can spell it out. One real solution. Okay. Next one, number 5. Again, this is not in standard form, so I want to put it in standard form by doing x squared plus 2x minus 1 equals 0. Okay, then I'm going to use that b squared minus 4ac If you memorize anything, memorize that right there. B squared minus 4ac. I'll have an annoying song for you to hear on Monday when we come back. So I'm going to plug in the b, so I have 2 squared minus 4 times a, which is 1, times c, which is negative 1. So then plug that in your calculator, open parentheses, 2 squared minus 4 times 1 times negative 1, and we get 8. So this is positive. So go back to that top. It's greater than 0. Right here, greater than 0. So there's 2 real solutions. 2 real solutions. All right, number 6. These you're going to see occur on your test, so please make sure you're paying attention. If you have questions, make sure you're going to ask them, highlight them so that we're ready to go. So what I want to do is I want to find my value of b, notice here's b, that has the discriminant of 100. So what I'm going to do is I'm going to use that same exact equation, b squared minus 4ac, and set it equal to 100. Well, I don't know b, so I'm going to keep it as b squared minus 4. A is 1, c is 24, equals to 100. And so I've got b squared minus, I'm going to do 4 times 1 times 24, and I get 96 equals to 100. So b squared equals, I'm going to do 100 plus 96, and I get 196. 196. So then, what I'm going to do is I'm going to take the square root of both sides. Again, remember, anytime you take the square root, it's plus or minus. So I have b equals plus or minus the square root of 196. But we need to see if that's going to simplify down at all. So I have the square root of 196, so 1 and 196, 2 and 98. There's a pause because I'm going back through and making sure that there's not any in here. Oh, there you go, 4 and 49, and we're going to pick that because of 49. So this actually becomes b equals plus or minus that square root of 4 and the square root of 49. Again, guys, some of you might have noticed, hey, Miss Milam, 196 is a perfect square. Why did you do that? If you don't notice it, it's okay. You can go through and find the ones you do notice, because here's what happens. The square root of 4 is 2. The square root of 49 is 7. 2 times 7 is 14. So you have plus or minus the square root of 14 as your answer. Okay. All right. So number 7. Now I'm finding the value of c. I'm still using the exact same thing. So my value of c is going to be, I'm going to have that b squared, which is 3 squared minus 4 times a times c. Well, I don't know what c is, so I'm going to let it represent by c, is equal to 169. So I have 9 minus 40, c equals 169. Subtract 9, I have negative 40c equals 160. Divide by negative 40. C equals negative. As we know, it's going to be negative. Plug in 160 divided by negative 40, and you got negative 4 as your answer. Then the question down here says, how many and what type of solution does this equation have? Well, we know my discriminant is 169, so therefore I know I have its positive 2 real solutions. Again, this is the number. This right here is the type. Okay. Last one that you have to do for today, and then again you're going to be working in page 5 of your packet. Please make sure you're doing it. You do have a piece of paper your sub will hand you that is due by the end of class today. I will be grading it and plugging it in, so if you don't turn it in, it'll be late. Alright, so here we go. I've got, again, I'm finding now the a value. So I'm going to have b squared, which is negative 3 squared minus 4 times a, which I don't know, so I'm just going to let that represent a, times 6, and it's going to be equal to negative 39. So 9 minus 24a equals negative 39. I'm going to subtract 9 from both sides, so negative 24a is going to be equal to negative 48. So a is equal to 2. There's my answer. Says again, how many and what type? Well, this was a negative, so I'm going to have 2 imaginary, non-real, complex, however you want to say it, and I just spelled imaginary wrong, so I will let you go from there. If you have any questions, play the video back or email me. I will be checking emails again. So have a great weekend, and I will see you all on Monday.